Okay, so good morning. That was a really great keynote from Julie. I hope everybody attended that. You'll see some similar themes through this talk as well. So I'm Randy Shoup, and I want to talk today about moving fast at scale. So I've been doing software for 30 years. Actually, I had hair before I started doing software, so you know how old that is. These are the places that I've worked in the last 15 years, and I've taken away learnings from all of them. Some of them, they're like learning things that I should do, and some of the things that are learning things that I shouldn't do. And actually, interestingly, I find that I learn more from the failures than from the successes, and that's actually going to be something that we're gonna see going through here. But what I want to do is talk about what are the things that really differentiate the high-performing organizations from the less well-performing organizations. In the past here at Build Stuff, I've talked a lot about microservices and how to do data and very sort of nuts and bolts technical stuff. This is not as much of a technical talk as it is a talk about the earlier parts of the product development process. So we'll talk about high performance culture, which I think is a core of doing just about anything. We're going to talk about organization in the form of autonomous teams. We're going to talk about, before we even write a line of code, defining what problem we're actually trying to solve. Then as we go through building our software, I want to talk about focus and prioritization. And finally, I want to talk about how we can build minimal viable features that are sustainable for the long term. So let's start by talking about high performance cultures. So as Julie mentioned several times, the Accelerate book, this is a fantastic set of research by Nicole Forsgren, Gene Kim, and Jez Humble. Really well worth a read. And one of the key things that they talk about are 3 different kinds of organizations. So the kind you want to be in is what's called a generative organization, and that's characterized by trust and sharing. So this is where people within a team trust one another, and teams within the organization trust one another as well. Less exciting is to be in a bureaucratic organization. I've definitely been in one of those where it's characterized by standards and rules and processes. And I've also experienced this, but you really don't want to be in this situation, which is a sort of pathological organization where everybody's motivated by fear and threat. Does anybody had that experience? I definitely have in the past. Yeah, I'm sure not anywhere that you're working right now, but in the past before. Cool. Well, so I want to talk about some of the characteristics of the generative organization, which hopefully you'll recognize. First off, I want to talk about some research that started way back in 1960 by Dr. Douglas McGregor, who wrote this wonderful book called The Human Side of Enterprise. And what he was trying to look at was leadership's beliefs about what actually motivates employees. And he has sort of goofy names for them, but I'll explain them. So he differentiates between Theory X leaders, Theory X organizations, and Theory Y. What did he mean when he said that? So Theory X is this idea that people are inherently lazy, they inherently try to avoid responsibility, they require extrinsic motivation. In other words, they need to be motivated by a manager or a whip or something like that. And this tends to lend itself to organizations that are very micromanagey and very uncomfortable to be in. By contrast, the Theory Y leaders and the Theory Y organizations have the belief that people are intrinsically motivated. They genuinely want to do a good job. They genuinely seek ownership of the things they want to do, and they want to perform well. And this wonderful graphic, which isn't mine, also sort of shows this differentiation. So in the Theory X situation, management's on the top and is kind of pushing down on the staff. Yuck. So it's very authoritarian, very repressive, very tight control, very micromanagey. Theory Y, on the other hand, is way more what we might call servant leadership. So management is in the bottom. It's about liberating and supporting and promoting the staff. It's about giving control to individual teams rather than centralizing it. And this the Theory Y organizations tend to perform a lot better. The other thing that's really important about these generative and high-performing organizations is this idea of psychological safety. Have people heard of psychological safety? Not enough hands. A good number, but not enough. So great, I'll tell you about it. So Google, being Google, did a bunch of research on how on their individual teams and what teams performed well and what teams performed poorly. And they had a bunch of hypotheses going in where maybe it was teams that had more PhDs on the team or people that had been at Google longer or something like that. It turns out that none of that stuff mattered at all. What mattered more than anything was this number one thing called psychological safety. And that's the idea that the team trusted one another. Or said another way, the team felt comfortable, felt safe for interpersonal risk-taking. And the idea is that people who feel comfortable coming to their team and being able to bring their whole self to work, whether it's their gender or their sexual orientation or their politics or all the aspects of their personality, and bringing that to their team without fear of negative consequences. And this was more important than any other factor in team success at Google. So this is a pretty powerful thing. Now, why do we think that might be? It's if I can trust you to, if I can trust that you guys are going to be nice to me and accept me as a person, I'm going to be much more willing to offer my honest opinions, and we're going to be able to have a healthy conversation and a healthy debate, a healthy collaboration around the stuff that we're building. Does it make sense what I'm saying? It's a fundamental core idea to anything that we're going to build in terms of software organizations. It turns out these other four things are also really important. Again, none of these are number of PhDs, number of years at Google, et cetera. So all things that are way more about culture than they are about technology, interestingly enough. The other thing I want to really highlight is the best teams that I've worked with do a lot of cross-functional collaboration. And in my experience, the best decisions that we make are made in partnership between the business and the product side and the technology side and maybe the support side or the customer side. And it turns out in my experience, that once we agree on the goals and priorities up front, that it's a lot easier for us to figure out what tactics to do. And when we tend to disagree, it usually is not because we have a fundamental different view of the world, but we lack common context. Does it make sense what I'm saying? That when we have the same information, we tend to be able to have a productive conversation. It's when we don't have the same information, where some of us know some things and the others know other things, that it isn't as useful. And then when, not if, we have disagreements, I love this idea from Intel, which they call disagree and commit. So this is something from way back in the 1970s. And the idea is that, again, with psychological safety in our organization, I'm going to make my pitch for the thing that I'd like to do. Somebody else is going to make their pitch. We're going to agree on what we're going to do. And even if we agreed on doing the other thing and not my thing, I'm going to commit to making that successful. Does it make sense? So I disagree, but I'm going to commit to making it successful. And that's hugely important to an organizational culture that's really powerful. I'm going to give a particular example from a time that I was at Google. So I ran engineering for Google App Engine, which is Google's platform as a service. And we had an 8-hour global outage where the entire world of App Engine all over the globe was out. This was a very, very bad day in fall 2013. And it was basically because of a bunch of legacy issues that Julie was talking about earlier, where we had accumulated a bunch of technical debt, we had a bunch of reliability issues that we had not prioritized, and it came back to bite us in a big way. So because we had a generative organization and we were pretty collaborative, we were able to sit down and get all the stakeholders in a room and sort of identify the problem. This is a sort of blameless postmortem approach to problem solving. So we had all the team leads, all the engineers, but also all the product people and business people, et cetera, all in a room. And we put up on the whiteboard, surrounding the room, all sorts of known issues that we had with reliability, but also things that we suspected might be problems as well. And we ended up, by the end of the several hours together, consolidating each of them into 8 or 10 different individual themes. Then we assigned those individual themes, or people volunteered to take those themes forward. And what we did is we time-boxed their sort of additional research. So we said, a week from today, the same people are going to come back in this room, maybe some more people, and we're going to talk about what we found, talk about the sort of research and thinking and potential projects we might want to do based on each of those individual themes. So a week later, we all came back, and as a group, in a consensus way, we discussed all the stuff that that people had proposed. We figured out, the small number of things that we needed to do right away. We prioritized those, and we got to work. And then the implementation sort of tactical part of it was pretty straightforward. So engineers worked on those assigned tasks to improve various aspects of reliability or system strength. And it was very minimal effort to manage it from the manager perspective. I was the manager, and it basically took me an hour a week. We just maintained a Google spreadsheet with a line of like each person and what they were working on. It was super simple, super lightweight, and we got a ton done. So the results were very quickly we ended up having a 10x reduction in the reliability issues that we've been having before. Even more wonderful was the effect on team culture. So we had a much broader participation and a much broader kind of feeling of ownership around those kind of reliability issues, because finally management was willing to prioritize them. Finally, we were getting an opportunity to improve those things. We had a much improved cohesion and camaraderie among the team. And then when I get together with my friends that we work together on this, we still all remember that. Remember that reliability thing? That was really cool. So even out of crisis, you can have something that can change the culture for the better and really improve things. So this I'm really proud of. That was high performance culture. Now let's talk about autonomous teams. So traditional organizations in engineering, like when I started 30 years ago, was there would be a bunch of people that would come up with an idea. So maybe we would call them the business or the product team or something like that. And they would throw their idea over the wall to well-paid typists like us. So we would develop software. We would throw our software over the wall to quality people who would try to figure out whether we produce bugs or not. And then we would finally ship that software out to people that would operate the software in the real world. What we have learned, and the research shows, this is not a great way to build software. This silo, handoff, silo, handoff, silo, handoff. Much better in modern organizations, we do it like this, where we try to put in one team the people that have the ideas, the people that do the development, the people that do the quality aspects of it, and the people that do the operations. And by the way, those don't need to be separate people. It can be, the same team doing all those different things. And then we divide them up into smaller teams rather than having one big idea team and one big development team, et cetera. And why do we do this? It's so that we can iterate faster, right? So we can make these feedback loops much shorter, maybe 1 week or 2 weeks rather than a year or 2 years. And we're able to just make a lot more progress and improve things a lot more quickly. It's really important that those teams be small. So people have probably heard of this 2-pizza team idea. 2-pizza team, yeah, lots of nods, that's great, thank you. So it's actually credited to Jeff Bezos, the founder of Amazon. So he liked to say a team should be no larger than can be fed by 2 large pizzas. And you have to sort of say 2 large American pizzas to make that make sense, I guess, but that's fine. So that tends to mean like 4 to 6 people roughly. As soon as you get to have a team that's like 10 people or larger, you want to try to see if you can split it up into 2 smaller ones. The other important thing is that these teams need to be aligned to particular problems in the business. So let's not have any more, as we used to have, like the front-end team, the application team, the database team. Why don't we want to do that? It's because every project would have to cross every one of those team boundaries. Does it make sense? Instead, let's have a team that is autonomous, that's able to have all the skill sets all together, but are aligned around a particular set of business problems, right? So with clear goals and metrics that actually matter to our customers, and then a well-defined area of technical responsibility that they're responsible for. So maybe one of those teams is responsible for one or a few applications, one or a few services, so a relatively small amount of the overall system, but that is particular to one particular area. And as an engineering leader myself, the metric that I set for myself is trying to see how can I form the teams in a way that the vast majority of their project work stays within the team. Does it make sense what I'm saying? So if it's something like maybe 20% of the team's work is able to be done by themselves and 80% of the time they're having to coordinate with others, I didn't do my job and I didn't draw the team boundaries in a very effective way. Whereas if we flipped it around and the majority of the team's work can be done without immediately all the time coordinating with other teams, then I've done a good job of drawing those boundaries. Does it make sense what I'm saying? Yeah. You could never get this to 100%. Because by definition, the big strategic priorities of your company are almost by definition going to cross a bunch of teams. So you don't even want it to be 100%, by the way, because if you did, every team like literally is like their own little company and there's no use being all together. Does it make sense what I'm saying? So you definitely do want large scale things that involve lots of different teams, but in an ideal world, let's try to make the teams be able to be autonomous and make, again, lots of forward progress without having to coordinate with other people. Cool. So that was a quick discussion of autonomous teams and sort of what kind of organizational strategy works well. Now I want to talk about something that I think we don't emphasize enough in software, which is defining the problem that we're working on. So if you remember nothing else out of this presentation, then I'd ask you to remember these 7 words. And these 7 words are going to be so powerful for you when you go back to your jobs, later this week or next week. And these 7 words are, what problem are you trying to solve? This is a wonderful question you can ask yourself in an introspective way, but this is also a wonderful question that you can use when you're talking to those idea people on your team. So who has had this experience where some person comes to them and says, hey, can you guys just add this button to the application? Yeah, let the record show that everybody's nodding and even some hands went up. Great. So here's what you can say. You can say, I would be very happy to do that, but please spend some time and tell me what problem we're trying to solve. Does that make sense? So what you are not saying is, no, I don't want to add your button. No, I don't want to solve your problem. But what you're trying to do is start a dialogue where instead of coming to the engineering parts of the organization with a solution, add the button, instead come to us with a problem and then let's collaborate and have a discussion about how to solve the problem. Now, it may well be that adding the button is the right solution. There's nothing wrong with that. But it's important that we have that conversation ahead of time. Now, I'm not suggesting that we do this for a week. Like, we could have this conversation for 15 minutes or 30 minutes, something like that. But it needs to be enough time that you and you can go away and have a really good idea of the problem that we're trying to solve so that you can apply your creativity to solving it in the best way. And one of the things that's really important that we bring to that conversation that I think we underemphasize or sort of appreciate about ourselves is we bring engineering discipline. So regardless of your educational background, by practicing engineering in the real world, you have trained yourself to be disciplined problem solvers. Does it make sense? Like, you're given a problem and you break it down into smaller things, like first I'm going to do this thing and then I'm going to commit it and then I'm going to do another thing and commit that. Like, our whole job is about taking some big amorphous problem, making it concrete, and dividing it into smaller steps. Not everybody is trained in that. In fact, few other people that don't have the daily practice of engineering actually do this. The thing that is our job in the conversation that I just said about understanding the problem is to help the person that we're talking with, help that support person, that customer, that product person, that business person, understand the problem in the way that we would and clarify it. Does it make sense what I'm saying? This is the value that we provide. We provide that disciplined problem solving. So as an engineer, when I've had lots of times in my career where somebody's come and said, hey, please, Randy, could you add this button, or could your team add this button? And in my head, I say, well, here's what I would have done. I would have thought about the problem. I would have thought about all the different, 4 or 5 different possible solutions. I would have thought about the different trade-offs, and then I would have decided, okay, the button's the right way to go, and then I would have proposed it. Does anybody think that that's what that person actually did? No, probably not, right? And that's what you can help them to do with your 5-minute or 15-minute or 30-minute conversation. Does it make sense like that? You're helping yourself understand the problem, you're helping them refine the problem, and you're going to build better software by taking that time to do it. Great. The other thing that we need to bring to that conversation is something that's called the curse of knowledge. So this is just a natural part of being human, that if I understand something, I think that you understand it too. And that's the curse. The curse of our knowledge is when I hear, Randy, please add that button, I go, oh man, wow, here's all the different things that is associated with that. I'm sure that person has thought about it, but like I have all these options and trade-offs and implications in my head. Oh, that's going to add to the technical debt load that we have. Oh, that's going to make it much more difficult to roll out. Oh, that's going to screw with the user experience of that page. Do you see what I mean? There's all these different trade-offs that I have in my head, and it's my job to say them out loud so the other person knows those too. Does that make sense? So again, helping that other person to go through that disciplined problem-solving process, but also helping them to understand the engineer things that you know, and you might assume that they know, but they actually don't. So it's our job to bring that to the conversation. Great. So this is a good start to, this is a good set of reasons why we want to clarify the problem that we're trying to solve. There are some other reasons too. So Marion Popendick 15 years ago wrote this fantastic book, actually 16 years ago, wrote this fantastic book called Lean Software Development. If you read it now, you would think that it was written in 2019 rather than 2003. It was so prescient, so incredibly modern. The only thing that doesn't look modern is like the code, the examples of the particular software that they're using. And they identify 7 different wastes in software development. The number one waste is building the wrong thing. So the critical thing that we need to do up front is understand the problem that we're solving so that we make sure that we're building the right thing rather than the wrong thing. And there are lots of ways to be inefficient in software, like I've done lots of inefficient things, but if I'm building the wrong thing, it's like 100% of my effort is wasted. Does that make sense? So really important to think up front and make sure that we really understand our problem. Okay, so if you're not convinced yet, hopefully this guy from General Motors, Charles Kettering, many years ago said this: a problem well stated is a problem half solved. That's why we do that disciplined problem solving for our part, because it helps us to break the problem down, make it more incremental to solve. So again, that problem definition process helps us in our daily job as well. It is very important. So Julie in the keynote had this thing where she said something like she really liked deleting code, except we're paid to write code. I think she was wonderful, and that was a very clever thing to say, but I don't think we're paid to write code. I think we're paid to solve problems. A lot of the times we solve the problem by writing code, but lots of other times we can solve it in an entirely different way. So when I used to work for Stitch Fix, which is a clothing retailer in the United States, we had physical warehouses all around the country. And one of my teams wrote software for the physical warehouses. And so a bunch of times we would have the warehouse people come to us and suggest improvements to the applications. They were absolutely fantastic to work with, by the way. And sometimes we would say, oh, well, let's fix the application in this particular way. But many times we would go through that kind of disciplined problem-solving process with them, and we would figure out, oh, you know what? If we just simply change the underlying business process, we wouldn't have to write any new code, and it would actually be a lot simpler. Does it make sense what I'm saying? Like, this is our value. Our value is not just being a well-paid typist. It is solving problems, and sometimes we solve those problems by writing code. Okay, sometimes we solve those problems by deleting code too. Great. Okay, so we talked about culture, we talked about organization, we talked about the thing we all really ought to be doing, which is refining and defining the problem ahead of time before we do anything. Now let's talk about focus and prioritization, and this is about how we're going to execute in the real world. So again, traditional organizations or traditional approaches to teams are kind of like this, and I will admit that as a team leader, I've done this many times. So okay, so I have this huge pile of features that I need to do, and hopefully they're in some kind of priority order in my backlog or something like that. And I have 5 people on the team, and I have more than 5 things to do. So let's see, I'll just put person 1 on feature 1, person 2 on feature 2, person 3 on feature 3, etc. And maybe in this made-up example, it's going to take us 4 months to ship something. This seems very natural, like there's tons of stuff to do, let's just get started on all of them. It turns out this is actually not a great way to run anything, particularly a software project. So we'll talk about some ways we can make this better. So the first thing that we want to do, oh yeah, if you're willing to take away more than those initial 7 words, then maybe you could take away 4 more and try these 4. So try taking away this idea of doing fewer things more done. Fewer things, more done. So what do I mean by that? So let's take that same 5-person team and those same features, and instead of spreading, the people very wide and working on 5 things at once, what if we worked on the highest couple of features first, and maybe we put several people on them? Now this assumes that it would be valuable, that 2 people could actually be productive on feature 1. Let's just assume that for the moment. That's not true of everything, but it's true of a lot of things, to be honest. So maybe let's have 2 people work on feature 1, let's have 2 people work on feature 2, and then the other person can work on feature 3. And then when those pairs of 2 get done with feature 1 and feature 2, maybe they can start on feature 4 and feature 5. Does this make sense? Now, what did I do here? Instead of waiting for 4 months or whatever to deliver any value to my customers at all, now I'm delivering value at month 2. And which value am I delivering? I'm delivering the highest priority stuff. Make sense? So already I've made a huge difference in terms of providing value to my customers more quickly than I otherwise would. Okay. I think we can do even better, though. So what if instead of releasing the feature as one big monolithic thing, what if we thought carefully up front and tried to break it down into smaller increments, right? So what if we instead, I'm making this up, but what if we instead broke feature 1 down into 4 incremental smaller releases? We broke feature 2 down in my example into 3 incremental releases, et cetera. And this does take a little bit of thinking up front. But it has the wonderful advantage of now I've delivered incremental pieces of value, maybe not in 2 months, but maybe every 2 weeks, something like that. It also allows us to get much tighter feedback. So we've released something, and we can see whether it works. Even if it's not even released to customers, we can see that it's interacting successfully with the rest of the system. We can see that it's performing well. There are lots of things that we can do that we can learn and optimize for by doing these tiny individual releases. It also makes us much more resilient to this. So who has ever started a piece of software and before they were able to finish and release it, the priorities changed? Let the record show that almost every hand went up. Cool. So the wonderful thing about delivering smaller units of work, fewer things, more done, or in lean terminology, reducing WIP limits, reducing work in progress, or smaller batch sizes. By producing smaller units of work, it allows us to be resilient to changes in priorities, because even if we get shifted onto something else, which is legitimate, maybe there is a higher priority in the company, there's nothing wrong with that, it's just at least we've provided value. Does it make sense? When we're in this situation, any time before month 4, we have produced exactly 0 value. Does that make sense? Exactly 0. The only value that we produce when we're doing the software part of our problem solving is when we actually ship software and customers use it in the real world, right? Everything along the way until we get to that point is useless. Okay. Great. Okay, so let's summarize what we learned about this. And by the way, we're just like re-deriving agile and lean principles from first principles, and I'm trying to use simpler language. So what have we done? So instead of having 5 people work on 5 things in parallel and treating the priority 5 one with the same amount of effort as the priority 1, what if instead we delivered the highest priority features first, and we treated the priority 1 as actually the highest priority, and we worked on that first, and then we got it done, and we did something else. We've delivered our full value earlier. So the full value of that feature 1 and that full value of feature 2, we actually shipped those to customers in this example, with half the time. And as you probably know from economics, like $1 or a euro today is worth more than $1 or a euro in a month or in 6 months or a year. And that's same as true as software. When we introduced that incremental delivery idea, we delivered value along the way. So we delivered increments of value instead of queuing everything up and delivering it all in one big chunk at the end. And it also allowed us to deliver value more efficiently, because a lot of times when I am pairing with somebody else, when I have two people, whether we're using one keyboard or separate keyboards, whatever, but when two of us are working on the same thing, we can unblock each other, can't we? Like when I reach a point where I'm not sure how to move forward, I can have a conversation with my partner, and she can often unblock me, and maybe I can unblock her when she gets blocked. Does it make sense what I'm saying? Like sometimes, not always, but sometimes two heads really are better than one. Great. So I want to give two real-world examples from eBay about how we did this, how we produced incremental value that added up to something really big. So the first example is what's called machine-learned ranking. So when I was at eBay, I helped build eBay's search engine. And people are probably familiar by using a search engine that a search engine has what's called a ranking function. So that's the function that scores the results and decides what thing to put in, the first position in the results, what thing to put in the second position, third position, et cetera, right? That's the thing that figures out what to order. It's called the ranking function. And the earlier part of eBay was basically a handwritten, very simple ranking function that was handwritten by a product manager. And it was pretty good. It lasted for years and years and years. But our hypothesis was that if we somehow could use, instead of a handful of factors, if we could use thousands of factors, we could actually produce better results. That was our guess. So we did a whole bunch of experimentation. We built some predictive models to help us figure out when people were looking for something on eBay, how often would they actually go view the item? When people viewed the item, how often would they actually go and purchase it? And we did a bunch of stuff to figure out what things would predict those steps in the purchase process. And we ended up doing hundreds and hundreds of parallel A/B tests where changing different factors and different weights for things. And we did a full year of, each individual improvement was not that big. It would be like 0.01% or something like that, barely noticeable. But it was actually noticeable. And by adding, a 0.01% here to a 0.01% there, and we added that up over a year, we ended up driving with this project alone a 2% increase in the overall revenue of the eBay company, which at the time was $60 billion a year. So this effort added $120 million to the bottom line right there. That was pretty cool. And again, no one thing made a massive difference. It was the practice and the process of incrementally trying this thing, that didn't work. Trying this thing, that didn't work. Oh, that thing does work. Okay, let's bank that 0.01% of improvement and then try something else, try something else, try something else. Does that make sense? Like very, very incremental improvements, which added up to something really big. At the same exact time as we were doing this, another one of my teams was improving the performance of the pages themselves. So our hypothesis as engineers was that if we made our pages faster, people would buy more. And as a side note, we actually had a really difficult challenge convincing the business that we should make the existing features faster rather than adding new features. And so we said, like, please trust us. I know it feels like we should add more features, but just trust us. Give us some opportunity to try to make the existing features faster, and we think it's going to make a big difference. So again, we went through a very iterative experimentation process where we would implement a potential improvement. We would do an A/B test where we would have the old version of the site for some users, the newer version of the site for other users, and we would monitor all the metrics that, the revenue and more technical details about page rendering and so on. And at the end of this process, we again got another 2% increase in the overall revenue, so another $120 million. And each of these was a couple of teams involved, maybe 15 people in total involved in the machine learning ranking, and maybe another 10 or 15 across a couple of teams in this one. So not a huge investment, but like a really huge payoff. This again, in both these cases, there was no one magic bullet. There was just slow, incremental progress, banking that, and then continuing to move forward. Make sense? Cool. Okay, so the last thing that I want to talk about is the discipline that we have when we're actually building features. And the way people have probably heard of this idea of the minimal viable product. I want to take that same idea, but I want to apply it a little bit, more targeted, in a more targeted way to features. So who's ever heard this? We don't have time to do it right. Yes, knowing laughter, many hands, lots of nods. Yes, I think we've all heard that. So here's another tool in your engineer toolbox you can use. Do we have time to do it twice? Because that's pretty much the option here. And interestingly enough, so I've worked at a couple of startups in addition to the big companies, and I've heard, oh, we don't have time to do it properly because we have so much to do. And I find that odd because if you take a step back and you think about it, almost the more constrained we are in time and resources, the more important it is that we get the one thing that we're working on and we get it done. And what I'm not saying is get it done perfectly and we're never going to have to change it again ever. But what I am saying is like, let's get it solid so we can leave it aside and work on the next thing. Make sense what I'm saying? And so I like to think about this as the minimal viable feature. And all of these three words are really important. The minimal part, like what's the simplest, stupidest, most straightforward way we can solve the customer problem with this feature, and let's just do that, get it out there, and get feedback. Viable. So it has to be like it has to actually work. It actually has to be reliable. I have to be able to like forget about it. Does it make sense? Like it has to be viable in the real world. It doesn't have to be super pretty. It can be a little bit, we're just trying stuff out. But it has to be viable. And then of course it has to be an actual feature that solves a customer problem. So what do I mean? And interestingly, your customers will thank you for this. So all of us carry these supercomputer. I'd put it away, but all of us carry these little supercomputers around in our pockets that we call our mobile phones. When the last time that you updated your mobile phone operating system, probably you did that regularly. Did you say, wow, there are 57 new features in iOS 13? That's so awesome. Said nobody ever. What you are actually interested in is the 1 or 2 or 3 features that actually matter to you. Like, oh, there's a great update to this app that I use all the time. The battery life is better. Does it make sense? Like the quantity of features, like nobody is measuring us on the quantity of features, or to be precise, no customer is measuring us on the quantity of features. What they are, though, is measuring us on the quality of features that we do build. Okay, so I like to build one thing that is done, or at least minimally viable, rather than 2 half-finished things. And I want to be super clear that what I'm not saying is done is perfect. I'm saying that it's done enough so that it works and I can move on to the next thing. So it's really more about the 80-20 rule, like what's the 20% of effort that I can put in to get 80% of the benefit. And when, not if, when we have many things that we want to do, it's way more important that instead of reducing the quality of the things that we produce, we just reduce the scope. Like instead of trying to produce 10 different things that are not that great, let's produce 5 things that are pretty solid, and then we can work on the next 5 things. Does that make sense? So the idea here that comes from Agile is having a definition of done. So when I say done, what do I mean? So what would be a minimal viable feature? Okay, so the first thing is like the part of the feature, the feature part, the actual functionality that we want to deliver to customers. So let's deliver a minimal viable feature there. I for sure want to have automated tests associated with it. Again, I want to be able to like leave it aside, not have to worry about it, so I can focus fully on the next thing. It has to be released to production. I can't tell you how many times I've had conversations with engineers on my team or others where I say, oh, how is it going on XYZ thing that you're working on? Like, oh, I'm done. Is it released yet? Oh, no, it's not released. Okay, you're not done. Or we're not done. And then other things where, okay, how are we doing on XYZ feature? Oh, it's released, great. Well, did we turn the feature flag on so if customers are using it? Oh, no, we haven't done that yet. Like, okay, we're not done. And then similarly, if I've released it to production and I don't have any way of sustainably monitoring it and understanding whether the feature's working or not, whether it's being used or not, it's also not done. Does it make sense? Again, coming back to that earlier idea, we are not done until there is actual value that we've delivered to customers. Make sense? Like nothing matters until we actually ship something. Okay, cool. I do want to talk a bit here about the huge power of test-driven development. So at several of the companies that I've worked for, we had really strong test-driven development cultures. Google, my particular part of Google was really good at that. Stitch Fix, where I worked, was really strong in that as well. And to the potential skeptics, whether in the audience or people that you work with, we don't write tests to go slow. We write tests to go fast. And what we're doing is we're making an investment up front in our ability to do the next job and the next job and the next job by simply writing some automated tests for this feature, so I basically don't have to worry about it again. Does that make sense? So when I'm making changes in some other area of the code, I know at least that I haven't broken this thing because I haven't broken my tests. I live in California, and I live near the coast, and I like to go running. And so sometimes I like to go running on the beach. It's really slow and really hard to run on the beach because the sand keeps slipping out from under your feet. It's much easier to run on solid ground. Your tests are the solid ground of your software. Does that make sense? It allows you to go faster exactly because the stuff that you're doing isn't breaking anything. Cool. And again, your tests are your safety net to catch again when you might break things. Tests also make better code because, to Julie's point in her keynote about refactoring, it gives us the confidence to like potentially radically refactor areas because we know that the tests are going to catch it if we break something. And it gives us the courage to do that really well. And also, tests make better systems because they allow us to catch bugs not at the time that we've shipped them to customers, but much earlier in the development process when it's a lot easier to fix them. Does that make sense? So if you and your collaborators aren't convinced yet, think about what developers actually do every day. So this is a 2006 study from Microsoft. It's probably pretty accurate today. And this is what we actually do day to day. So you might think that we're adding new code all the time. Turns out that we're not really doing that. We're spending 75% of it, particularly in legacy systems, maybe even more, 75% of our time reading and understanding existing code, maybe 20% of the time modifying that existing code, and maybe only 5% of the time writing new code. Now your numbers might be different, but I guarantee you you're reading existing code a lot more than you are writing new stuff. And it turns out that test-driven development helps with both of these things, right? It helps us to read existing code because tests are executable documentation, and it certainly helps us modifying existing code but because it makes sure that we don't break things. It actually also helps us write new code, but I'm happy with 95%. Cool. Okay. So at Stitch Fix, again, we had a very strong test-driven development culture, and as a consequence, we basically didn't really have a bug tracking system. Now, we produced plenty of bugs. Like, it's not like we were magical software developers. We were very average, to be perfectly honest. But the process allowed us that when we produced a bug, we would typically find it pretty early in the development process. And even if we did find a bug that was released to customers, we hadn't accumulated such a massive backlog of bugs that we could just fix it. Right? Oh, that just came up. Great. Okay, I'm going to stop what I'm working on now. I'm going to fix that bug, and then I'm going to go back to it. And you could do this too. Like, these weren't magical people with some magical different kind of software than everybody else. This was very straightforward, regular people with regular software working in the regular world. And the only difference, or the major difference, was this discipline around test-driven development. I can't tell you how powerful it is. And it allows us to turn what can often feel like a vicious cycle of like, oh man, we've got a bunch of technical debt, we don't have time to do it right, so we put in some quick and dirty hack, so we accrue more technical debt, so it makes it even harder to do it right the next time, round and round and round, and gets worse and worse. And instead, by adopting, I think minimal viable features, incremental deployment, test-driven development, we can have a solid foundation, which gives us the confidence to write really good software, really simple software, allows us to be faster and better. We can do more investments in the testing and the development process, and we can have a virtuous cycle. Okay, so we talked about the base, I think, the culture, which I think is really important, high-performance culture. We talked about organization in the form of autonomous teams. We talked about making sure we really define the problem that we're solving up front. We talked about focus and prioritization of where we put our resources. And we finally talked about minimal viable features and strong development practices. And so again, by reference back to the Accelerate book, they make a distinction between sort of low performers, medium, high, and what they call elite. And so the difference between the elite performers and the low performers are that the elite performers are releasing code, deploying code 46 times more often. Their lead time, the time between when I commit my code to source control and it actually gets deployed on site, is 2,500 times faster in these elite organizations. They have a 7 times lower change failure rate. So the amount of time that when I ship something to production that I have to roll it back or hotfix it or something like that, 7 times less, and also 2,600 times faster time to recover from incidents. So these techniques really do matter in the engineering metrics that we care about every day. But even more importantly, they matter in the business metrics. So the other thing that this research shows is that those same high-performing organizations are 2.5 times more likely than the low performers to exceed business goals like profitability and market share and productivity. So it doesn't just matter to engineers, it also matters to business people and to the company itself. So thank you very much. Okay. All right, so I'm not sure how long we have for questions, but I'm sure they'll stop me. When applying the iterative approach and only doing minimal improvements, how do you decide when to stop? That is a great question. You decide when to stop when you're no longer producing customer value that matters. So I think probably something that I should have said is making sure that we have metrics that decide at least whether knowing when our features or whether our features are being used, but also like what value they're actually providing. And so we stop when the incremental cost of producing a feature is more than the value that we're going to get. Does that make sense? Cool. One more. Did you put in did you put any OKRs when starting to work on search improvements? If yes, how did you come out with a predicted number? So that's a great question. Let's see, we did have goals. We didn't have formal OKRs at eBay, but that's not the important part of the question. I think what you're asking is, did we know we were going to get the 2% improvement? Like, no, we did not. We just had a hypothesis that we could make an improvement in the revenue and the usage of the search pages by, again, having the ranking be better and by making the pages faster. We had no idea, to be frank, when we started, whether we were going to get a 0.1% improvement for revenue or 1 or 2. We had a pretty good idea that since we'd never done any work on performance or any work on the ranking improvements before, that there was a lot of room for opportunity, but we really didn't know ahead of time what we were going to get.